Good day, I'm Dr. T. Welcome to my office, and I want to talk about safety. But in order to do that, I need to get a few ideas into your brain so that we can start reformatting the way we think about safety. Because the traditional way we think about safety has a bunch of arbitrary rules. Well, I'll get into that. It's not great. It's better than nothing, but it's not great. Okay, so to get some ideas into your brain, let's start with a fairly straightforward one. That's called safety culture. Every organization, every group of people has its own culture. Now, obviously, your society has the dominant culture, and every other group is going to kind of spawn off of that culture. And one of the things in your culture is its attitude towards safety. And once again, specifically, I'm talking about, say, your company or your school or the group of people you're working with, their attitudes and beliefs about safety. This can range wildly from we take no risks to, whatever, people just get hurt, we don't care. People just get hurt, don't care? That's not good. That's a safety culture in which I'm not going to tell you to walk away from that group. I'm going to tell you to run. You want to make sure you're with a group of people that value your safety. We don't want to have an attitude of, who cares what happens? Bad things just happen. Because if we have an attitude of bad things just happen, guess what? They're just going to happen. Because they do happen unless you take precautions to stop them. Now, we normally think about safety as following a set of rules. And of course, some people, their attitude is rules are meant to be broken. What the safety inspector doesn't know won't hurt him. It won't hurt him, it'll hurt you. So if we think about safety rules, typically these were created because someone got hurt. The environmental health and safety folks like to say that the safety rules were written in blood. In many cases, that is almost literal. You know, they still use an ink pen with normal ink, but you get the idea. This rule exists because someone died. Now, if we can reframe our safety culture to one where it's not, well, we got a bunch of rules we have to follow, but instead of, well, how do I make sure I go home at night? How do I make sure that I and the people I care about are safe? How do we get the job done and get to go home when we're done doing the job? Because life isn't about the job. Life is so much more than just the job, and you don't want to give up your life for a job. It's not worth it. So let's do things in a way that keeps everyone safe, respects everyone, and still gets the job done. Because you know what? We still got to get the job done, but we can do so safely. Now, once we got our safety culture hopefully aligned with the idea that we're trying to be safe and everyone gets to go home and retire and live a nice, long, happy, healthy life, and that, you know what, that's more important than getting the job done, but we still got to get the job done, then let's start thinking about the way we start implementing safety. Generally speaking, if you're setting up policies and procedures, you're going to want to make sure that those policies and procedures are ones that are going to help your employees do the job safely. Well, what about risk? What about things that could go wrong? And you could think in kind of two ways. Do I want to set up safeguards that protect my employees from things that will go wrong? Or do I want to set them up to protect my employees from things that could go wrong? In other words, a burden of proof. Do I set something up as a protection from something that I have proof is a danger? Or do I set it up as a protection against something that I can't prove isn't a danger? There's the old saying, it's not the one you see that gets you, it's the one you don't see. And such, we want to make sure we're thinking in terms of, you know what, the burden of proof is on it being safe, not on it being dangerous. Okay, so we've got some attitudes to think about. Let's actually use those. We've got the right attitudes, hopefully. We're going to try and do everything safe, but we're still going to get the job done. Let's think about how we actually do that. And to do this, we kind of need to know what we're going to be doing. We have to have a plan, a procedure. Typically, the phrase in a lot of industry is a standard operating procedure. Basically, the standard way we do whatever we're doing. And in many cases, these will actually be written out, possibly even full-on checklists. But even if you're not working for an organization that has full-on checklists to check off exactly how you're doing things, you should at least have in your mind what you're going to be doing. And once you have a plan, you can do the next step. That is a risk assessment. With a risk assessment, we're going to be looking at two things: hazard and likelihood. Hazard is how bad something could be. If things go wrong, how wrong can it be? And likelihood is exactly what it sounds like. How likely is it? Risk is going to be the combination of the two. Something that is very likely but not very bad could be a moderate risk, and something that's very bad but very unlikely could still be a moderate risk. Something that's likely and very bad, that risk is through the roof. So let's actually kind of graph it. So over here, I'm going to plop a risk assessment matrix. There are tons of these out on the internet. This is one I mocked up in Inkscape just to make sure to comply with intellectual property laws. And respect the other people that created their own. This is, by the way, Creative Commons for anyone who would like it. Okay, so risk assessment matrix, I'm looking at my paper copy over here, down towards the origin. So we're going to do a graph, XY graph, and towards the origin, that's going to be the really boring side. The x-axis is going to be the likelihood, so near zero, it's incredibly rare. A once-in-a-generation event. Most people will go their entire lives without ever experiencing this particular outcome. Versus very likely on the other side. So on the extreme positive end of the x-axis, everyone experiences this all the time, constantly, multiple times an hour. And then we go for the severity. It's really minor. It has no real particular negative impact. Versus on the positive end of the y-axis, it's extreme, mass casualty event. Another way of thinking of severity is, how will it be remembered? On the bottom of the severity scale, the person probably isn't going to remember it 15 minutes later because it was just that minor. On the top end of the severity scale, there will be documentaries made 50 years later talking about the horrors of said event. Looking at you, Union Carbide. Okay, so as we are relatively close to the origin, the risk is low. We've got low likelihood and a low severity. I like to call this the who cares corner. Who cares? This is not something worth worrying about. We have got other things to worry about. As we get a little bit further away from the origin, either the severity is going up or the likelihood is going up, or both are going up a little bit. Then we get into kind of a moderate risk and something that we may find acceptable or we may not. We may need to take steps to mitigate this risk. As the severity goes up and or the likelihood goes up, then we get into a higher risk where we may not find acceptable, depending on exactly what we're doing. And then eventually, as the severity and the likelihood both go up quite high, this is an extreme risk and is something that cannot be allowed to happen. And no matter how much we want to do what we want to do, this is just utterly beyond unacceptable. By the way, when I'm talking about unacceptable risk, I probably should put up a different chart. Also, sketch this thing up in Inkscape. Let me find my Dead Tree edition for it. There it is. Okay, this is a risk-reward graph. Actually, this is like 3 different matrices squished into one because they're all basically the same matrix. So on the y-axis, we're going to put some kind of negative thing. This is going to be risk, could be cost, and could be effort. Now, these are 3 different things. I can spend money to make it easier and safer. But now I spend more money. So in reality, what I'm showing you should be like this n-dimensional grid of things. And then on the x-axis is going to be, the benefit I get from it. So reward, benefit, impact, however I want to phrase good stuff. So high up on the risk category, you know what? This is something to start thinking about. If there's not a lot of reward or benefit to a high-risk activity, you're in a category where you should just avoid. So everything in that kind of quadrant, hey, it was an idea. Don't do it. Just don't. It's not worth it. It's either too expensive, too unsafe. This gets into kind of the old is the juice worth the squeeze kind of scenario. Okay, now, same thing. It may not have a lot of benefit, but if we are low on the risk, cost, and effort categories, it might be something you consider if you've got nothing better else to do. So yeah, some folks will put this as the filler content. Now, if the rewards are high, well, then if it's not particularly costly, it's safe, cheap, and efficient, Hey, just do it. This is low-hanging fruit. Go for it. And if it's going to be risky but a great reward, then, well, you know what? It's something to consider. But these charts usually don't have the part where you start maxing out the risk. Once the risk gets high enough, it doesn't matter how good your benefit is. It's just not worth it. It's one of those things, at any cost, is an awfully high price to pay. Okay, so we're thinking about risk assessment. And we actually want to take a step back. We're doing our risk assessment matrix. We're doing our risk reward matrix. We're thinking, what's the risk and is it worth doing? While we're doing that, we also want to think a little bit about how we can get risk a little bit wrong. We as humans are bad at judging risk. We have some biases. We generally bias towards things that are more a security factor, something where we're trying to stop a malactor, a person trying to hurt us, instead of safety. Safety would be trying to prevent an accident from causing harm. So we're kind of biased towards moral actors and may overemphasize that, as in hindsight probably was the case with terrorism in the early 21st century, and downplay things like accidents or other events that maybe are unintended consequences. For instance, deaths due to cigarette smoke, etc. You could argue there's a moral actor here, and I'm not going to get into that argument, but one person dying from smoking a cigarette doesn't feel the same as a bunch of people dying in an act of terrorism, even though actually more people died, even in 2001, from cigarette smoke and its complications than did acts of terrorism. So the subtle things, the things that don't have a good story, nothing really flashy, nothing that's sticking in your brain, are the ones we kind of underplay. And the things that have a good story, a narrative, those we overemphasize. A lot of people are afraid of flying, and despite a certain American airline manufacturer trying to do otherwise, airlines are actually quite safe. Driving, on the other hand, is not nearly as safe as one would think, but we've grown accustomed to it. A car wreck happens. It feels more random. It feels smaller. A couple of people died in a car wreck, and quite often we can probably blame the driver in that case. Not always, but we quite often can make a story that allows us to think, oh, well, that's them, not me. Whereas an airline, someone flying as a passenger on an airline, they're not in control of the airplane, so I can't make a narrative where, well, that wouldn't be me. And a whole bunch of people died at once. It was a massive news story, even though those are very, very rare, whereas car wrecks are actually much more common. Cars are, mile per mile, more dangerous than flying. So we want to think about our own personal biases. Formally do a risk assessment. Actually write these things down. If this is a major event, if this is something we're doing a big project, we actually want to do a formal risk assessment. Now, as we're doing that risk assessment, if we find out that, you know what, the risk is not where I want it to be. I want the risk to be lower. We're not in that nice who cares corner. And we're maybe acceptable, but we're definitely borderline. How do I lower the risk? Well, to do so, I'm going to need this critter, a hierarchy of control. The hierarchy of controls is a list of steps we can take to reduce the risk of any activity that we're doing. Now, I should always say that we're talking in terms of reducing risk. Risk never actually goes to zero. The likelihood of some horrible event may be very tiny, but it's never actually zero. But once again, we want very tiny. Very tiny is usually good enough. So the top of the hierarchy of controls. So I've got a pyramid here, and the top level of this pyramid, because in this case the pyramid's upside down, so the top level is widest, showing that it's the most effective, the most potent, and possibly the first one you should be considering, and that is elimination. If your activity is just not safe, maybe you should just not do it. Maybe there's this component of the activity that you're doing that you could maybe just not do. Is a certain feature absolutely essential to what you're doing? For example, going about your day. Is smoking an absolutely essential part of your day? No. I mean, you might have an addiction, but if you could get rid of the addiction, stop smoking, you would remove the risks associated with smoking. that is the first approach. Just don't do it. Now, of course, quite often that is not an option. If you are, say, trying to light your house and boil your water, you're going to need energy. That's probably going to be a form of electricity. So just not having electricity is, generally speaking, not an option. So we could do substitution. Could we run at a somewhat lower voltage? Something a little bit safer here. This is actually something we do here in the United States. Our electrical plugs and electrical outlets are actually kind of pathetic. If you listen to, say, British YouTubers, they will wax poetic about the impressive features of their electrical outlets. These are, of course, the tech YouTubers. The normal YouTubers probably don't wax poetic about electrical outlets. And in the United States, let's just be honest, our plugs are kind of meh. But we do something a little bit different. In most of the world, definitely in the United Kingdom, the voltage going to everyday appliances, such as your toaster, is 220 volts or so. This creates a lot of power, a lot of energy per unit time that can be used to boil water, toast bread, turn on LED light, whatever you'd like. In the US, we actually cut the voltage down. We actually cut it in half. We take that 220, split it into two halves, and so the toaster only gets 110. That's less power. It's going to take more current, or it's going to take longer in order to get the same amount of energy moved. But if you cut the voltage in half, the risk from an electric shock from an American 110 is a lot lower because the amount of hazard is lower. We haven't changed the likelihood, instead we've reduced the hazard. A 110 jolt is definitely unpleasant and could cause serious harm, but a 220 is pretty much going to cause serious harm. So we're lowering the risk by substituting 220 for 110. Fairly straightforward. Now, going down the inverted pyramid, we've got engineering controls. So we're going to keep whatever thing is creating the hazard, but in this case, we're going to put something between us and it. And this is what the UK tech YouTubers typically like to wax poetic about their electrical outlets and their plugs. Their plugs are loaded with all kinds of engineering controls. Extra safety features to ensure that everyone is safe. I'll let you listen to some random British YouTuber wax poetic on that one. I'm not British, and I don't feel like waxing poetic about electrical outlets. I know Tom Scott has a really old video that does so. Okay, so engineering control. We simply put something between us and it. This can work quite often. You've got safety guards on things, fail-safe mechanisms, and other features of devices to keep everyone safe. If you look at a handsaw from the 1950s, you definitely don't feel like plugging that thing in. There are very few engineering controls. It's got a switch, not a trigger mechanism, so if you let go, it keeps going, and it may not have a guard to prevent you from accidentally chopping something you don't want to chop off. Modern handsaws, they have a lot more engineering controls, a lot more safeguards on it. New table saws even have ones where the saw self-destructs if you accidentally touch the blade. Kind of a cool feature, also rather expensive. Now, moving down the list, maybe you don't feel engineering controls are needed, or you've applied engineering controls, but you still want improved safety. And this is kind of the lowest level before we start digging, and that is administrative controls. Literally tell people don't do something. If you've got an area of your equipment that is particularly hazardous, like the cutting blades of a saw, tell people keep your hand away from it. Put down some tape and say, don't cross the tape. Don't let your hand cross this line. Now, administrative controls are the weakest of these controls because people, let's just be honest, don't always listen. Or, accidents happen. They trip, they stumble, they weren't trying to cross the line, but they still crossed the line. And as such, if you've got a particularly massive hazard, an engineering control is definitely going to be a lot better than an administrative control. But for lesser hazards, or in conjunction with engineering controls, administrative controls are quite good. The tip of the pyramid, once again at the bottom, is personal protective equipment, or PPE. Now, with the exception of some things like gloves, PPE I like to think of as buried, because if the PPE is protecting you, this is going to basically be protective clothing or garments or shields, etc., that are on you. If they're protecting you, Well, all the other controls have now failed. You should have all of the other controls. Gloves are a slight difference. Occasionally you don a pair of gloves to stick your hands in the goop, etc. And they are the front and last line, and that's fine. They do a good job, depending on the glove and the goop you're sticking it in. But for the most part, if, say, you're wearing goggles and some weird chemical gets on the goggle, well, that goggle is the only thing that protected you from having your eyes burned out. You should treat that as a near miss. Assume that next time it may not work. So you want to make sure it doesn't happen a next time. But personal protective equipment is an absolutely critical layer. It is your last line of defense between harm. Okay, so we've got ourselves our hierarchy of controls. Hopefully, we've been able to make our system a little bit safer. But there is actually one thing we need to do after applying our controls. We need to redo the risk assessment. Why do we need to redo the risk assessment? Because the standard operating procedure has now changed. We have now changed our plan because we've added our engineering controls. And there are cases where safety devices or security devices create new hazards or change the likelihood of other hazards happening. For example, heavy personal protective equipment will protect you from a lot of things, but it may very well increase your body temperature in warm environments. While there wasn't a heat stroke risk to start with, or it was relatively small, if you're wearing 20, 30 pounds of protective garments, yeah, if it's summer down here in the South, you now have a much higher heat stroke risk than if you weren't wearing those. So once you've applied your various hierarchy of controls, you've changed your procedure, you got to redo that risk assessment. Okay, so we've talked about the plan. Let's talk about problems once we run the plan. The first one I want to mention is loss of situational awareness. So that's when we're focusing on what we're doing and we're not paying attention to what's going on around us. This could be that we're hyper-focusing on the project, or it could be that, say, we've got a pair of earbuds in and it's blocking our ability to hear what's going on around us. You want to pay attention to what's going on, making sure you're keeping situationally aware, and those people working with you are doing the same. A lot of companies will have something like a no earbuds policy or a one earbuds policy. So the idea is an earbud sits in the ear, it blocks out your ability to hear, but you got two ears, well, at least most of us do, and so if you put an earbud in one, then you can listen with the other. Alternatively, there are specialized earbuds and earmuffs that don't actually block the ears. They allow ambient sound to go in. So depending on what you're doing, those may be adequate or permitted for what you're working with. However, in some cases, you need your full focus scanning the environment. So really, any kind of distraction is not a good idea. Now, we normally talk about distractions as being unrelated things, but you can enter into what we call information overload. So in this case, your distraction is your job. So you're trying to do something and you've just got too much information hitting you too fast. And because of that, you can't process all of the information quick enough, and you can't prioritize what you need to focus on versus what you don't need to focus on. An interesting related topic to information overload is that of alarm fatigue. We humans are built to tune out irrelevant information. When an alarm goes off, hopefully we're conditioned to stop what we're doing, pay attention, and address the alarm. But if the alarm keeps going off, we just grow accustomed to it. If the alarm doesn't actually have relevant information to us. For instance, if you have a faulty system that's triggering on things that are not harmful. Of course, Aesop's fable, The Boy Who Cried Wolf, shows us the downsides of this. Potentially, that alarm will one day be for something real, something important, something meaningful, and we ignore it, and bad outcomes happen. For this reason, you need to think about alarms both in making sure they trigger when they need to, but they don't trigger when they shouldn't. You don't want to have a massive alert for no apparent reason, or for a reason that is quite unimportant. This is one reason why meteorologists are very conservative when they draw tornado warning boxes. They want people to immediately take shelter, but they don't want to have a whole bunch of people take shelter and there be no tornado anywhere near them, and so that the next time there's a tornado, those individuals don't bother taking shelter, and, well, maybe they should have. So you want to be careful with your alarms. You can definitely overdo them. Remember The Boy Who Cried Wolf. A few other issues that can lead us towards being in a somewhat riskier situation than what we would expect. We live in a world where things change. That's just the nature of existence. And we need to be aware of those changes, maintain situational awareness, but we also need to realize that sometimes the risk matrix is not where we thought it was, and we are not in a safe location. So if the situation has gone from acceptable to unacceptable, then we need to take steps to address that and potentially stop what we're doing. But as humans, we have what we call completion bias. I've started, I'm gonna finish this thing. And this can be dangerous, depending on what you're doing. Generally speaking, in chemistry labs, completion bias is probably going to lead you to break something expensive, but usually doesn't hurt you. In other areas, it could very easily lead to injury or death of individuals, where we proceed in a riskier situation. And once again, depending on what you're doing, that could be in most situations. The classic one is when you're driving, the weather gets bad, the weather gets really bad, at a certain point you need to pull over. An even worse point, you need to pull over, get out of the car and lie in a ditch because a tornado is coming right at you. But you want to get to where you're going, so you keep driving even when it's probably no longer safe. A related scenario is that when we're working alone. We humans are the dominant species on the planet because we use tools and have friends. Friends are incredibly helpful. Having someone around you changes the risk assessment for you. If you get injured or hurt, if they're within screaming distance, they're going to be able to render aid for you. What could be a serious but not catastrophic injury could easily escalate to potentially a fatal injury if you don't have immediate aid in the facility. So when you are working, if you are going to be alone, so you're not within earshot of anyone, you do want to reassess your risks, as what may have been a relatively minor or maybe moderate risk, it could easily escalate into something more severe if you can't get help in the event of emergency. Additionally, someone around you is also going to help maintain situational awareness, etc. If one of you sees the problem, then hey, it's easier to tell there's a problem when someone's screaming at you that there is a problem. This is one of the reasons why you want to make sure that everyone on a project has at least a basic understanding of what's going on for the full scope of the project. Individuals that are working in a somewhat blind situation are going to be following their directions to the best of their ability, but they may be taking steps that inadvertently create hazards or potential problems for other individuals because they don't understand the scope of the project. Additionally, they may observe things taking place that indicates that something has gone seriously wrong. If they don't know what's going on, they may not be able to perceive the problem that they're currently looking at. If everyone on the project has at least a basic understanding of what's going on, then they're going to be able to avoid creating problems for other individuals, and they're going to be able to observe potential hazards and alert those individuals that need to know about that. More eyes is generally better. There is a leadership philosophy. In the military, I believe it's called Mission Command. There's a couple different versions of it in the corporate world, but the general idea is that each individual is trained on what they're doing to the point of 2 levels above them. So you have a general idea of what your boss's boss will need, and you're thinking about your boss's boss's needs. That way, you're able to spot problems and potentially address them, as well as avoid creating problems in achieving your goals that may have downstream impacts. Now, one of these areas that I want to discuss is probably the most insidious of all the things that can go wrong with a plan, and that's what's called normalized deviance. Basically, you're doing the plan, you need to improve efficiency, or you need to make it easier, or there's a problem with the plan. The plan isn't quite working, so you're going to fix it by deviating from the plan a little bit. And that becomes normal. You just normally deviate a little bit. And the problem with normalized deviance is, one, we can get into slippery slope category where we start deviating more and more. But even if we don't get into slippery slope, where we simply have a simple deviation from the plan, if we don't rerun the risk assessment, we may be introducing other hazards that we didn't plan for. This could easily involve disabling some form of engineering control, or this could be doing something in a different way that creates whole new hazards that were just never considered in the first place. So we want to watch out for normalized deviance. The longer we do something and nothing bad happens, the more confident we get in doing it. If we haven't actually looked at the risks of it, that could lead to a situation where things become quite dangerous. This is generally where you get spectacular disasters in what seem like ultra-safe environments. The plan was not actually followed. There were problems with the plan, and instead of fixing the plan, it was just worked around. The last point I want to bring up here is a comment about ethics and when you're working under someone. If someone tells you to do a job that is going to either be dangerous to yourself or others, probably illegal, or potentially really, really expensive, oops, going on, so, you know, a big expensive thing gets destroyed in the process, your responsibility is to tell them no. When it comes to anything illegal, obviously if you do the illegal stuff, you are probably going to be considered an accomplice. By the way, I'm not a lawyer. I'm definitely not your lawyer. Go talk to an actual lawyer if you have a problem. But, you know, if your boss is telling you to do stuff that's illegal, well, it's illegal. If it's highly dangerous, well, once again, your boss might get in trouble, but if you're going to be in the hospital, you're still in the worst spot. Or, you know, worse than that. So protect yourself and protect others. Generally speaking, most countries have laws such that you can't be fired for refusing to do an unsafe job. There's a lot of caveats there, and once again, talk to a lawyer. I'm not a lawyer. I'm definitely not your lawyer. And the last one is a little bit less extreme, but if it's going to be a really big mistake, something that's going to be dreadfully expensive, definitely tell them no. If they insist, demand the insistence be in writing. Once again, you want to protect yourself when things go south. Also, you are a much more valuable employee if you are able to tell your boss, I understand what you want me to do, but that's a really bad idea, and here is why. For anyone that's working for me or under me or with me, if I'm going to do something stupid, I want them to stop me. That is going to be valuable for your boss. Think what they need. And definitely, if it's illegal or dangerous, just don't. It's not worth the downstream risk. So with that said, I hope you've enjoyed this video. Have a wonderful day, and I'll see you in future videos.